Classes provide a means of bundling data and the functionality together. So these data functionalities could be methods, could be properties, or any behaviors that you want to associate it with, what this data is, right? So class kind of just encapsulate all of them. And you can define the initialization conditions, right? And any sort of operations that allow on the data. So let's just look at this class definition. Sometimes people call it definition and declaration. They're interchangeable because now, because this is declaration, so we have to make sure that there is a semicolon at the end. You can also define, right, its own behavior, meaning all of the business logics in there. So this entire class definition can become a definition in general. So this is the syntax for declaring a class. You start with the class and then name the class, right? And whatever is in there, let's take a look at it. There's this area called public. This means that all of the information that you have underneath it, they're publicly accessible. So these are methods, right? They're public. Now by default, default access to members of a class is private. And this is true in C++, may not be true for our other OOP. So you got to be careful about that. So the private members are not accessible outside the class. They can be accessed only through methods of the class, meaning these methods can have access to X and Y. However, if you have a instantiated instance of CRECT at runtime, that instantiated instance cannot have access to its private data. But this also means that depends on where you organize your data, right? You can effectively hide some of the implementation details. And this makes OOP very, very powerful. So this is what we call data encapsulations. And then you can decide on what part of the information or that data or that behavior, right, could be shared across. So let's look at more closely the examples of how we make use of these class informations. So this is the same class that we looked at called CRECT. There's a privately accessible data X and Y. So let's just say if we instantiate the CRECT on the stack, right? So this is not dynamically instantiated. So on the stack, and then we try to invoke using the dot operator, rect.x, to do something with it. You can't. This actually generates an issue at runtime. You cannot have access to rect private information. However, you can instead invoke area. So this area is a method that is under public, which means both set underscore values and area. These two methods are publicly accessible. So when you instantiate an instance of a rectangle, you can invoke on this rectangle's member function area, but you cannot directly access that rect's private information. However, this area itself, right, in its own implementation can access any private information, but not the instance itself, okay? So got to be super careful about these. And the other thing about this is entirely user-defined, right? You don't see this as in any C++ library. So you can write your own user-defined, right? Then we said class is a data type, whereas object itself is a variable. So CRECT, right? This part is data type, okay? And this rect is a variable at runtime. In the next video, we're going to look at members of these classes, specifically data members and methods that are associated with these classes in more detail.